Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to be looking at Lesson 7, more quadratic word problems, found in Chapter 10 of your workbooks. And if you don't have a workbook, that's all right. I'm glad that you're here with us right now. Now, in Lesson 6, if you remembered, Lesson 6 dealt with the first part of quadratic word problems, but those word problems were more like the riddle type and the figure this out based on this information. But what we're going to look at today is where quadratics come in play, mainly with like projectile motion. Okay? And that's what it says in that first paragraph. It says, perhaps one of the most useful applications of quadratics is projectile motion. Since gravity is constant on Earth, which means anything that goes up must come down, and it happens in a parabolic path, the shape of a parabola. Today, we're going to work with projectile motion, analyzing different situations and interpreting the solutions. So, looking at exercise number 1 right here, a ball is shot from a cannon into the air with an upward velocity of 40 feet per second. That means it's moving up into the air at 40 feet per second. The equation that gives the height h of the ball at any time t is shown below. And you see that equation h of t equals negative 16t squared plus 40t plus 1.5 right there. All right. So now, what is the maximum height the ball reaches? Justify your answer. So keyword that we want to look at right away is maximum. And another name for maximum starts with a V, vertex. There we go. So we have vertex is another name for maximum. So there's one way that we learned a couple of lessons ago, actually last chapter, how to find the vertex given an equation in standard form. And it was a two-step process where the first step we wanted to do was we wanted to find the axis of symmetry. And then after we found the axis of symmetry, we wanted to use that x value and substitute it into our equation to get the y value. So this is just one method, one way of doing it. And we'll talk about other methods after we finish this part of the exercise. So axis of symmetry formula you should remember as x is equal to negative b divided by 2a. So we're going to substitute in x is equal to, well, what's our b value? It's 40. So we're going to write negative 40 divided by 2 times, what's the a value? Negative 16. Remember, keep the sign that's in front of each of the coefficients. So now we're going to have negative 40 up top, and we're going to have negative 32 down on bottom. And if we wanted to divide those, we would divide 40 divided by 32, or negative 40 divided by negative 32. It's going to give us a positive answer of 1.25. So now that we know our axis of symmetry is x equals 1.25, and we know the axis of symmetry cuts our parabola in half, because let's say this is let's not do that. Let's say that this right here is a graph of our parabola. Our axis of symmetry is going to cut it in half. Not only cut it in half, it's going to touch the vertex, or the maximum in this case. So if we know that x equals 1.25, we actually know the x coordinate of our vertex. Another way that we're going to get our y coordinate is we're going to substitute in 1.25 for t. So instead of h of t, I'm going to go over here and I'm going to write h of 1.25 is equal to negative 16 times 1.25 squared plus 40 times 1.25 plus 1.5. Okay, a lot. You could go ahead and you could go do that in your calculators, or you could try to do it in your head. That's cool too. But might be a little tougher to do in your head. So right now, I'm going to do it out right now. I've got, let's see. I got negative, So I've got 1.25 squared gives me 1.5625 times negative 16. That's going to give me negative 25 right here. Okay, 40 times 1.25, that's going to give me 50 there. And over here, I'm going to have plus 1.5. So I believe if I were to add those all up, I would get 26.5. So h of 1.25 is going to be 26.5, if I believe it. Okay, and now that also gives me the y-coordinate of my vertex, 26.5. So what is the maximum height the ball reaches? 26.5 feet, because that's the y-coordinate of the vertex, and the vertex is the maximum height. 26.5 feet is the maximum height. And when it says justify, it just means show your work and use math to do it. Did we do that? We sure did. We used a lot of math here. All right. So now let's look at part B. How many seconds will it take the ball to hit the ground? Round your answer to the nearest hundredth of a second. Okay. So this one is saying that we're allowed to round our answer. So that's a good thing. Because we don't need simplest radical form. And how many seconds will it take for the ball to hit the ground? Hit the ground is saying where is the roots of this graph, or the zeros, or the x-intercepts, right? Or the solutions. So what we want to do is we want to take this equation that we're given, negative 16t squared plus 40t plus 1.5, and we're going to set it equal to 0. Now we have three options here, guys and girls. Our first option is to solve this by factoring. If I'm going to look at this, I see an a term that's not equal to 1. I see a decimal as my c term. I'm not going to factor. No way, no way. So that brings me to my second method, which is completing the square. And it's tougher to complete the square. It's doable, but it's tougher to complete the square with an a term that's not equal to 1. So I'm going to go to my third and my final method that we learned in this chapter of finding the zeros, and that was the, rhymes with Quadratic formula, quadratic formula. Yes. So we're going to get that formula right here. We're going to list it out. X equals negative b plus or minus the square root of b squared minus 4ac, and that's all divided by 2a. In addition to this, we're going to need to know what our a term, what our b term, and what our c terms are. Our a term is the number before the t squared, and that's going to be negative 16. Our b term is the number before the t, and that's going to be positive 40. And our c term is the constant by itself, which is going to be 1.5. So now we're going to substitute those a, b, and c values into our quadratic formula right up above, and we're just going to replace the a, b, and c values with those numbers up there. Keep everything else exactly the same. So we're going to have negative, the b value is 40, so we're going to have negative 40, plus or minus the square root of 40 squared minus 4 times a, which is negative 16, times c, which is 1.5, all divided by 2 times a, which is 2, times negative 16. So I'm going to simplify this one piece at a time, okay? So I'm going to just copy it down here. We're going to keep that negative 40 plus or minus for now, and we're going to have the square root. Now, what we want to do here is let's do 40 squared. Okay, that'll give us 1600. And then we want to do 4 times negative 16 times 1.5. That's going to be 96. So we're going to have 1600 minus negative 96. So minus negative will make it a plus. So that's actually going to be 1696 inside those parentheses, and divided by negative 32. So yeah, we'll actually change that right here just to make it neater. 1696. That's 1600 plus 96 right there. Uh-oh. So now it said that we are allowed, thank goodness we don't need to simplify that radical. It says that we are allowed to express our answer as a decimal. So the first thing we want to do to find out what the decimal is going to be is to find the square root of 1696. And when you do that, you're going to get, we'll write it up here, x equals negative 40 plus or minus, because our roots have a positive or negative solution. And we have 41.18252. And I'll stop it there because it wants me to round to the nearest hundredth. So if I keep an extra 3 places for now, I'll definitely ensure myself safety right there. Okay, so now I'm going to take my negative 32 down here, and I'm going to solve this for the plus value and then again for the minus value. So for the plus value, I'm going to have negative 40 plus 41.18252. And I'm going to divide that by negative 32. Yes. And I'm going to get negative 0.03695. Okay, if I do the other method where I do negative 40 minus negative 41.18, I'm going to get up top, that would give me negative 81.18252. And I'm going to divide that by negative 32. A negative divided by a negative will give me a positive 2.53695. Of these two answers, it wants to know when it's going to hit the ground. Well, we can't have negative time, so we're going to reject that first one. Reject this one because you can't have negative time. This is going to be our answer, but we want to make sure we round correctly. The nearest hundredth, well, that's the 10th place. That's the 100th place. So we want 2 decimal places. The 6 tells us to round the 3 up. So it's going to be 2.54 seconds. This thing is going to hit the ground. Okay, I believe we have one more part to this question, and that one part is how long will it take the ball to first reach a height of 15 feet? Round your answer to the nearest hundredth of a second. So this question is saying, based on this equation right here, negative 16t plus 40t plus 1.5, when will it be equal to 15, right? It wants to know when it's first going to be equal to 15 feet. So we set it equal to 15. But now the way we solve this is to get this whole equation equal to 0. So we're going to have to move that 15 over to this side. Okay. And we have negative 16t squared plus 40t. And then we're going to have negative 13.5 here equal to 0. Now that it's equal to 0, again, we want to find the solutions now. Yes, the solutions are where it equals 0, but again, remember we added this 15 into the equation. So now when we look for the solutions, it's really looking for where this equation equals 15, not 0. Okay? So using that, we're going to use the quadratic formula once again, because again, we have decimals, a coefficients greater than 1. Nah, I don't want to deal with any of that with anything other than the quadratic formula. So I'm going to write down my formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And I'm going to substitute in down here. I'm going to have negative, oh, well, we didn't write out our a, b, and c values. So let's do that, just so we know for sure. We're going off of these values. So we have an a value of negative 16. We have a b value of positive 40. And we have a c value now of negative 13.5. So we're going to have negative b, which is negative 40, plus or minus the square root of 40 squared minus 4 times a, which is negative 16, times c, which is now negative 13.5. All right, divided by 2 times a, which is negative 16. Let's simplify this a piece at a time. So I'm going to simplify that square root part first. So let's see what we're going to have simplified inside there. I have 40 squared, which I know is going to be 1600, minus, and then I want to do 4 times negative 16 times negative 13.5. Right there, I'm going to get 864, positive 864. And divide that by 2 times negative 16 is negative 32. So now inside my square root, I'm going to have negative 40 plus or minus the square root of what's 1600 minus 864? Well, that's going to be 736 divided by negative 32. And again, we're going to want the square root of 736. And the square root of 736 is, well, let's recopy that negative 40 plus or minus 27.1293. That's enough decimal places. Divided by negative 32. Okay, so let's just take a look at this. We're going to need the positive, we have two answers. Let's do negative 40. So we're going to do negative 40 plus 27.1293. And then we're going to take that answer and we're going to divide it by negative 32. We're going to get 0.40, and that's rounded to the nearest hundredth. But also, if we go the other route and we do negative 40 minus 27, so we're going to get negative 67.1293, and we're going to divide that now by negative 32, and we're going to get a positive 2.097, which is going to round up to 2.10. Now, based on these two answers, we want to know when it's going to first reach a height of 15 feet. So again, it will reach a height of 15 feet at both of these times, because remember, what goes up must come down. So if this is 15 feet, it'll reach at a time of 0.4 seconds, go up, go up, go up, and then come back down and reach another height of 15 feet at 2.1 seconds. But the first time it's going to reach a height of 15 feet is going to be at 0.4 seconds. Okay, I hope this video helped you out. Many parts to this exercise, A, B, and C. We got through them all. And if you thought that this video was helpful to your learning process, please give it a thumbs up below. Okay? Thanks.